Today we're going to be talking about SAT statistics. And the reality with SAT statistics is that it's not really that hard and it doesn't really show up a lot of times. Likely going to give you one variable quantitative data, and quantitative just stands for like numbers. So for example, let's say I give you something like this. Yes? And I have a number here, right? Let's say I have 2, 3, and 4, and then I have these dots representing people, and or something like this, no? And then they also have two variable quantitative data, which will look more like this, stuff like that. And then you generally will have like a line of best fit going through that. But we're going to be referencing this first. Okay, so center, spread, and shape of distributions. All right, so what does center actually even mean? Well, the center just means, it means a typical value of a data set. And the SAT covers three measures of spread, and that's going to be the mean, the median, and the mode. So mean is just gonna stand for average, and then let me just lower that. That's a little bright. And then median is gonna stand for middle. And then mode is not really so tested on this exam, but it's the number that shows up the most. So most common, we'll say, right? And now the spread. So this is all measures of the center. And now spread, we have standard deviation. Now there is a formula for standard deviation, but for the sake and purposes of the SAT, you don't really need to know it. You just kind of need to know how it works. So you have a standard deviation, and then you have the range. Now I'll get more into what these mean later. We're just going to focus on these three right now. And these are all going to be measures of spread. Okay? So just for the sake of confusion, every single like data set for this sake and purposes of the SAT will have a mean, median, and a mode. You will never only have one thing, and same thing with this and this. You're always going to have standard deviation, you're always going to have a range. Alright, so consider this these numbers, right? Now, for the sake and purposes, what's the mean? How would you find the mean? Well, the mean is just going to be the average of all of these things, no? So it's going to be all of these things divided by the total number of things, right? So the mean can really just be summed up as sum over values, right? So the sum is going to be 2 plus 5 plus 6 plus 7 plus 10, all of the amount of values, which is going to be 1, 2, 3, 4, and then 5. So boom, right? I'm going to take my time with this. 6 plus 13, 20, 13 plus 10 equals 30 over 5. Oh, sorry, this is all going to be over 5. Apologize for that. And this is just going to be 6. So that is a really basic example, but it's good to know for future reference. What if I asked for the mean of this? Well, the mean is just going to be, again, the number in the middle, so it's just going to be 6. So it's perfect, right? It's just going to be 6. Median equals 6. Right? Now here's where the problem comes in. Let's say I add a number, 11, right? So I have a number 11. There's no if I count from the left to the right, you're going to realize that there's nothing in the middle, right? There's absolutely nothing. So what do? Well, I mean, it's pretty intuitive actually. We're just going to take the sum of these numbers and then we're going to take the mean of the two middle numbers, or the average of the two middle numbers, right? So our median is just going to be 6 plus 7, right, over the total values here, which is going to be 2. And this is going to be 6.5. Now if I add 3 more numbers, right, and I ask for the mode, what would it be? Well, the number that appears the most is just going to be 11. So it's just going to be 11. That's the mode for this. And that's really what it is. The mode is not really asked for a lot. Here's one type of data set that you might see. And here's a common question that you might actually find yourself going into. So let's say they give you this, no? So this is what we call a dot plot, and essentially we're given numbers here, right? And everything has, and let's say we're given this circle, boom, 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 and let's say we have a number here, 25. There's nothing there. So usually SAT questions like to ask this. They always like to. You really have to be fluent with comparing med, and means. You really have to be fluent with that. And the simple way of understanding it is like this. If your distribution is skewed this way, is skewed right, in other words, it's empty right, this is really going to be the breakdown. Your median is going to be here, and your mean is going to be bigger. And why? And this is true because the median is actually resistant to an outlier, right? So right here in this scenario, we have this outlier. Well, it's a possible outlier of 24, and the mean is going to be affected by that, right? The mean is going to increase because of that. The median is not going to be affected, right? Your median is still going to be this 21, probably, right? So if you count from left to right, you're still going to get this 21. It's still resistant. The mean is going to change a lot, though. This mean is going to be significantly affected by that. And the same thing would happen if I were to have it right here, okay? Right. So which means that if it's skewed left, my median actually ends out being less, or my medium actually ends up being bigger than my mean. Okay, so there's that. Now here's the really cool thing though. If the distribution ends up looking like this, where it's perfectly symmetrical, right? Then the median and the mean are actually the same, right? So let's look at a question. All right, so unfortunately for these types of questions, you can't really use Desmos for these. You kind of just have to like know it. And this is one example, right? So a geologist uses beryllium. So again, they love to use like science. It's kind of just BS though. It's kind of extraneous 10. So you want to circle this number because this is a total of 10 on a circle. Now, if this number was bigger, if it was like 100, then you're not really going to be counting like all this. But since it's a smaller, relatively smaller number, it's pretty nice. Which of the best compares the median and the mean? All right. So again, they really love comparing the median and the mean, and you can kind of sketch out like a little line, and you realize that it's kind of skewed this way. I mean, it's kind of skewed right here, skewed right. Meaning, if you remember what I showed you, right? The median is going to be here, and then the mean is going to be here, right? So our mean is going to be bigger than our median, because there's more numbers that are dragging this way. It's dragging the mean, it's dragging the average up, while our middle number stays exactly the same, right? So right here, A. First of all, this is not symmetrical at all. The mean or approximate, because this distribution is symmetrical, it's not symmetrical. So A is wrong. The median is lower than the mean because 2 of the samples are several years older than the rest. So the median is lower than the mean. So this is probably going to be our answer. Let's hold on to it. The median is higher than the mean because many more of the samples at 25 years or less exposure. Well, that doesn't really matter here. The mean is not going to be higher. That actually doesn't make any sense. If anything, it would make it lower. The logic does not make sense, right? If they had 25 years of experience of less exposure, then I mean the mean is just going to be bigger there. So I mean that's just not right. And there's plenty of information. It's just B. So students at a school in different states calculated the volume of snow they took to fill 1 cup of water after the snow had melted. The results were this, or that. To the nearest tenth of a cup, how much greater was the mean than the median of their calculations? Now here's the thing that you need to never lose sight of the fact. This is not in order, which means you cannot get the median by merely just like calculating the average of these two, because it's not in order. You have to write it in order first if you want the median. So let's go. Let's write it in order: 2.2, 2.5, 2.5, 3.0, 3.7, 3.9. Okay, so we have our numbers 1, 2, 3, 4, 5, 6. So our median is just going to be 2.5 plus 3 over 2. Let's see what that actually equals. This is going to give us 2.75, right? And then to find the mean, you're just going to add everything up. So I'm not going to write, I'm really just adding all of these numbers right here and then dividing it by the total values, which is 6. So I'm going to do that separately. You're going to realize that the mean is going to be 2.96. And it's asking you how much greater, so you're going to subtract it. 2.96 minus 2.75. I'm sorry, well, this is going to be 6 repeating. To the nearest tenth, it's going to be 0.2. Alright, so let's look at this question. Alright, so you have all of this, right? And so what it's basically saying is, so these are a number of home runs hit by players. And they're saying, if the player who hit the most home runs was removed, so if this guy's gone, what happens? What happens to the mean? Right, well, simply put, the mean is not going to be resistant. Right, the mean is not going to be resistant, which means it's not going to remain the same. It's going to either decrease or increase, and there's plenty of information to answer the question. Right, so it's going to increase or decrease. The median is resistant, right? If I were to remove this guy, the median would not change at all, but our average is going to change, right? And the thing is, this guy's pulling everyone up. He's carrying everybody, right? I mean, he has everything. I mean, except for this guy. He's not carrying him, but you get what I'm saying. He's carrying everyone on his back, right? If this guy goes away, the average goes down. Okay, so it's got to decrease. It's got to decrease. Right? If you remove a high value, the mean is going to decrease. If you remove a low value, the mean is going to increase. That's really how that's going to work. This next key concept you guys are going to have to dial in on is called box plots. Now, how are box plots formed? Well, let's see. This is like the average. This is a very symmetrical the most symmetrical box plot, right? So this is going to be your minimum. This is going to be your maximum. And this is actually going to be your median. So this line right here, no matter if it looks like, no matter if this line is here or here or here, doesn't matter. This line will always be the median. Always it will be the median, no matter what, right? And now these things right here is going to be quartile 1, and this is going to be quartile 3. So quartile 1 and quartile 3, it's going to be like the 25th percentile of numbers. So for example, if I were to have, let's say, 3, 4, 5, 6, 7, 8, and 9. If I were to have these numbers, right, our median is going to be this. So I'm just going to mark it with an M. And then our quartile 1 is going to be this middle number right here. So this is Q1. And then our quartile 3 is going to be this. Quartile 2 is going to be the median. So this is quartile 2. But we're just going to call it the median. right? So this is another key concept you guys really need to dial in on if you want to do it on the SAT. You might see a box plot and you might have zero clue what's going on. So let's go. Here's an SAT problem. You're given it's asking collected data and these are the box plots. How much greater was the median of the musical tickets than the median of the non-musical tickets? So remember what I told you, right? This line right here is this line right here is always going to be the median, no matter what. It's never going to be the middle of between this. It's always going to be this line, no matter what, right? So here it's actually pretty visible. Right here it's a kind of a weird line, but just know that this line in this little box right here is always going to be the median. So let's see what this points to. This is a roughly 95, and this is 80 approximately, right? So it's asking the difference. How much greater was this than this? So we're going to do 95 minus 80. That's going to give me 15. Now here's something we haven't seen yet, right? So we have categorical data here, and they're matched with something here. Now here's the really important thing you have to take away here again. Remember, these are not in order, so they are not ordered. So immediately if they're I don't even know if they're asking about median, or they're probably going to ask you to compare the mean or the median or something like that, or they're asking for the median. Just be careful, right? This is not in order, so you need to be very, very careful with this. What is the difference between the mean and the median ticket prices rounded to the nearest dollar, right? So the mean is pretty easy. Add all these numbers and divide it by 7. So let's do that. I'm just going to... And our mean is going to end up being 374.4. Our median is not going to be, it is not going to be this. This is not our median. Let's say that, let's move this right here, okay? Let's pretend there's something here, and I'm just going to remove this, okay? Let's move that up there. Now it's ordered. Okay, so this is going to be 1, 2, 2, 3, 1, 2, 3. Our median is going to be 345, so 345. Then we're just going to subtract it, 345. And once you subtract it, you're going to end up getting 29, or not 2.9, 29.4, and round it to the nearest tenth, it's just 29. All right, so here's another question regarding the median, and I did say that the median is resistant to outliers. The mean is not. The mean will always be affected if you add a new thing. In this scenario, this is what's happening. The median is resistant, but you have to be careful because this is not really an outlier. This is going to be probably like near the middle. So you really have to see how the middle is going to shift here. Now, if you have like 1, 2, 3, 4, and then they tell you, and then they add 100, well, the median is going to be resistant to that. Yeah. The median is not really going to change. It's going to change slightly by by 0.5, but it's not going to change that much. Whereas the mean would increase by so much, by a lot, right? But what they're basically asking us to do, it's almost like they're asking us to add another 3 here. If I were to add a 3 here, what would happen, right? But let's just get into the question, no? So I'm going to order these first of all. So 4. All right. So let me just order these by 4. Okay. So our middle number here is just going to be 1, 2, 1, 2. It's going to be this, the average between these numbers. Okay. So let's find that. So I'm having median before, and the median before is going to give me 5.195. Now we gotta find the median after. Okay, so if I have 5.61, that's just gonna go right here. It's gonna go right here. Now the beautiful thing is, if I add it, right? If this is probably gonna end up going right here. So which means that's gonna become our new median. Our new median is just gonna be 5.61 because it's basically gonna be added in the middle. It's gonna be added in the middle, right? Or you can add it here too. But regardless, this number will shift over and they'll become the median. So either way, you're getting 5.61. So now I'm just gonna take the difference between these, or just the difference. I'm just gonna have the absolute value of that. So I really just want the difference, how much it just changes by. Just like that, and your answer should be C. All right, so I have a question here. There's reasoning behind every single one of them, except for this one for some reason. But we're just gonna figure this out right now. The bar graph summarize. So right here is the first instance of a bar graph. Summarizes different from a histogram, by the way. It's different. And that you could watch a video on that, but just know that it's different. And it's not really that important for this anyway. Summarizes the whole household size of a social worker's client families, which statement describes the relationship between the mean. Again, they want you to compare the mean and the mean, or the median and the mean, right? Now, if I were to sketch this, it kind of looks like this, and then it just drops. So as you can see, there kind of is a little skew on this right side. And remember what I said, right? There's 2 different instances, right? Boom, or boom, like that. Or it could be perfectly symmetrical in this case. It's definitely not, right? So I'm going to just use text here, right? So let's say, my median is going to be here, somewhere here, and my mean is going to be here, meaning that my mean is going to be greater, right? And then in this scenario, my mean is going to be here, and my median is going to be here. Meaning in this scenario, my median is bigger, right? And because it's skewed, right, this looks like this. The mean is going to end up being bigger, so it's A. It's this one. And the reason, I mean, it makes logical sense, right? The median is sort of resistant to the outliers that are, right here. The median is not really going to change if I keep adding stuff here. The median is not going to like change, but the mean is definitely going to get a little higher. So it makes sense that the mean ends up being higher, and this is always the case.